So gas laws. So I just had a couple comments here because there were questions that came up during office hours. One is the summer schedule showed up. So if you're in take 223, I have it listed. It's me. It's the second half of the summer. So it's a 5-week class. So it's like this double pace. So it's 4 days a week, but I have it split into 2 sections. So there's one section that's 1 to 3, 4 days a week, Monday, Tuesday, Wednesday, Thursday. And during that time, I'll be doing what I do now. Like we'll do the study set and then I'll do the lecture and I'll record it. And then there's an evening one. I only have that one listed 2 days a week because I'm figuring it's not going to have as many people, and that those of you who take it, you're going to have worked all day. And so you're going to get to watch videotape lectures, but we will have meetings at least twice a week to go over the study set and other questions. And I'll have office hours for you guys also. So we'll figure that out, or you can ask me. Second question is extra credit. There's been 2 opportunities for extra credit. There's actually a third one I think I posted. I wrote it and I don't know, but there was one, it was supposed to come in with your solids lab, and 2 people actually did it, and they were really, really fun pictures. So I made it open through next week. Because some of you might decide after you take the test that maybe you should do extra credit, or it's going to rain Thursday and Friday. So it's a really fun extra credit. Damon actually did the whole thing. If you have children in your life, do it with them. They'll be better at it than you. And there was an extra credit opportunity with, I think it was lab 5, it was 4. I don't remember the numbers anymore. It was that you could watch one of those videos that was listed at the end of the lab. It's when you had to cook something in the kitchen. Anyway, if you want to do that, you still can, and then you would just submit it. And then there's going to be another one. I think it's in the folder. It's a surface tension, extra surface tension. And it's also, it's not problem solving. It's like, you have to be playful. You have to not take yourself so seriously. And so last year, actually, about half the class did that one. So getting a point or 2. There's 4 different activities you can do. And if you win any, you get double point. So then the lab for this week, because we are in the 6th week, so we're in the hump week. So we are 5 weeks ago, we started. 5 weeks from now is the final. So our 3rd celebration, we don't have a final. The lab for this week is, again, you pick 3 different activities to do. One of them can be problem solving, but some of them are 7 days. So if you haven't taken a look, or baking, and so, or playing a music instrument, or you can sing. So if you have questions on that, just make sure you've looked at the lab in case you want to do one of the 7-day ones, that you can get that started. All right. So this is not study set 3. Sorry, I renumbered the study sets from last year. So that's why, like labs, I renumbered 2. So that's why sometimes the name of the lab is a different number than what it actually is. So 654 millimeters of mercury is our pressure one. And into 123. So volume 1 is going to be 123 milliliters. My pen is not going to work. And then we go into, we transfer it to a new volume, 321 milliliters, and I want to know what's the new pressure. So you can underline or highlight, get a highlighter, or make a list of your variables. So the key is the variables, and then you will state the formula. So this is just pressure and volume. So P1 V1 equals P2 V2. My recommendation is that you make like a note card or a piece of paper. So when you're taking the celebration on Thursday, we're going to do a review for the celebration. So there's a study set and then we'll do a review. But you will get 3 hours. In class, they would have 2 hours because there's a lot of problem solving, which takes more time. And so it'll be similar format and stuff. And so we'll talk more on Thursday. All right, but you're going to always state your formula. And then you plug in or rearrange and plug in. So we're solving for P2. We would divide by V2, and then you would plug in. So this one I'm going to actually plug in. So pretend like it's your celebration. So you would state your formula. And when you plug in, you would show your units or your worksheet today. So make sure your formula is stated. Make sure you clearly plug in 123 milliliters and 321. So a comment for you guys, because I got to grade your solids lab. Half of you showed your work beautifully where you stated and you showed units and I could follow. And some of you were a little sloppy. And you might have gotten to an answer, but it's showing your work in the process so other people could follow it. So you can fix mistakes or retry stuff and resubmit it. You will lose points because it is then a late submission, but you might be able to gain some points. All right, on number 2, we have volume. So if you prefer, you can make the list like I did on number 1, or you can just underline and label. And this is where a different colored pen can be helpful. And this would be our T1. And we're going to a new volume, and our T2 is our question mark. So this is going to involve volume and temperature. I like to put my temperature on top because I'm solving for temperature. If I was solving for volume, I would put that on top. So whatever you're solving for, that should be in your numerator. Solving for T2, so then I rearrange. So always state the original formula and then rearrange. So we'd plug in, so V2, you want to also label. So whether you make a list or you label by underlining, that's kind of your preference. We have the V2 is going to go first. The V1 is going to be on the bottom. And what you need to remember about temperatures is you're always going to change to Kelvin. So I do not need to see this step. This is just as a reminder. And a question that came up from several people, you're always going to be adding 273. It was a comment about sig figs. And you guys all know the answers were up there, so you could check what you got. When you add 273, you're always going to end up with 3 sig figs. So sig figs are important. We're into the math. That was another thing. That was probably the biggest thing on the lab this past weekend. Solids, because it's math, that a lot of you were, your sig figs were kind of all over the place. And so we haven't really been doing the numbers math. So we do want to respect sig figs. Temperature is always going to have 3 sig figs because when we change it, well, not always, but it's probably going to have 3 sig figs because when we change it to Kelvin, and you have to be in Kelvin. Why do you have to be in Kelvin? It's the only temperature scale that works. Anybody know? Max, it's a chance to get on the board.
Gas laws don't work in Celsius.
Why, Maddie?
I don't know why.
Wasn't it because Kelvin was made around gas laws, whereas Celsius was made around the boiling and freezing point of water?
I don't know if that's true. You are right. The Celsius was based on the boiling point of water. What Kelvin did is 0 Kelvin is where there's no movement. Gases are about movement. They are about chaos. They are all about movement, kinetic energy. And the Kelvin scale is the only scale that took into consideration the idea of kinetic energy, which is what gas laws work off of. And so that is why you have to be in Kelvin. That's a really good question. Maybe I should put that on your test. You're going to solve, you'll be in Kelvin. So we'll get what, 292-ish Kelvin. And then you would subtract, 272, 270. Let's try it again. 270, good math in my head. Subtract the 273. You can have a negative Celsius temperature. So Celsius can be positive or negative. Kelvin, we are not going to see a negative Kelvin temperature. The other comment I wanted to make was to go back to number 1. So our answer came out in millimeters of mercury. And this is a question I often get, not necessarily from my 222, but as long as you're doing this ratio problem where it's P times V or T over V, your units just have to cancel out. So we did not need to go to liters. You could just keep it in milliliters. and you could keep it in millimeters of mercury. You did not have to change it to ATMs. When we use R, which we do eventually on the next page, then you have to have the units that match that R constant. Temperature, though, is always Kelvin. It doesn't work in Celsius, again, because it didn't take into effect the idea of jiggles and giggles and wiggles. Oh my. If my headphones start doing that weird thing again, somebody tell me. They were doing that earlier. And I'm dressed like a fairy because the elements, we've been walking through the elements. So earth, water, air. And so the elementals are the gnomes. The gnomes are actually chemistry things. So the gnomes actually protect and represent the earth. Water is represented by the mermaids, and fairies represent the air or gases. We don't talk about ether, but that would be really cool. You can do a diagram, you can do a beautiful sketch. Actually, I have one somebody made for me last year, and they brought it to my house for this lab. And so I'm staring at it right now, which is cool. Yeah, so if you want to dress up, either for the review or the exam, as your favorite elemental, you can go for it. You can just wear a noff. You can wear your favorite hat. That hat doesn't count, though, Max and Tristan, so it's not. I mean, it is enough, but if you dressed up as Captain America, though, Max, if we get you the face, I could borrow mine. All right, so next one, 245 milliliters. So we're going to call that V1. At tells us this is my T1, and the Tor is our P1. So again, you can make a list, or you can just put those all together, and then you can even use a different color to underline your other ones. That my ATMs is my P2, and this is my T2. So this one has pressure, volume, and temperature. So that full gas law, this is one of the ones that, like, I had a note card. This would be one of the ones I would have on there. The full one has the N in there, which you need for doing the worksheet today. We just leave the N off because there's no mention of moles on this question. And we're solving for V2 as our question mark. So again, if you prefer the list, absolutely do the list. Circle that piece that you want and then rearrange. So T2 is going to be on top. We cross multiply, and P2 is going to be on the bottom. So you can't have pressure times pressures. That would never happen. And then you just want to fill in. So we have to add the 273s. We have 296. Then P1, and you can cross them off as you use them. P1 is 543. The other one's an ATM, so I'm going to go ahead and switch it. So we would do 1 ATM over 760 Tor. I personally like to do it within the problem. So I just do one setup and punch it all in my calculator. And then our V1 is 245 milliliters. And then in the denominator, we're going to have P2. It doesn't matter. We just get in the habit of changing to ATMs if one of them is in the ATMs. But you could have changed the ATM to Tor with the 760. And so that takes care of that. And we want our T1, so 310 Kelvin. And you just punch it in, and you should get the 136 milliliters. Milliliters, because my other unit was milliliters. I didn't specify the unit, so if you did it in liters, that was fine too. You just have to have your unit there. Any questions on those first three? Gas laws is the first thing that's going to be on your exam on the celebration on Tuesday. And that's a good thing, because that usually relaxes everybody, because it is just formula based. So identify, make a list. We'll make a list on this. And again, I keep saying it's study said 3. So we have 30 kilograms of helium, one of the noble gases. So I read an article. This was article yesterday. Google sends me wonderful articles. In space, the noble gases form compounds that they cannot form on Earth. I did not get very far in the article, but I thought that was kind of cool. All right. That is a huge amount. We have a pressure So pressure is 1.23 atms, and we have a temperature. So our temperature is 21, and then you can just change it. So add your 273. Again, this is the one step I do not need to see. When you change to ATMs from Torr, I do need to see that, which we don't have to do here. And the question wants to know, what's the volume? It is going to be a huge, crazy volume. The K stands for 1,000, so 147,000, because that's a huge mass. So we only have one of each variable. PV equals nRT is the formula we want to use. And we're solving for volume. So state the formula, circle your variable, and then isolate that variable. So state the formula how it is. Again, the full gas, this is the ideal gas law. That's one you can always go back to. So if you want, you can do your math over here in the columns. I like to do it in the problem. So I just take my 30 kilograms. Sorry, change my kilograms to grams. So multiply by 1,000 grams per kilogram. So you have to show your work. And then helium is 4.003-ish grams to 1 mole. So some people will show the work over on the side, which is fine. It's like a personal preference. Just make sure it's done neatly, like over on the side, and then I can clearly see where the numbers are. You can just state R as R, or you can state the number 0.082057 is the number we are going with, which is ATM liters per mole K. If you write the number, put the units in, so our mole will cancel, our grams, our kilograms cancel, and then my temperature is 294 Kelvin. And we divide by the 1.23 ATMs, which will cancel that, and we get 147,000 liters. Back to questions about sig figs. These had 3 sig figs because all the numbers did. Again, temperature, when you add the 273, it goes back to that. On number 2, when we subtracted the 273, that restricted our sig figs. So questions on the first page. All right. On our second page, study set for Thursday is a little bit different. The first page has math. The second page is the theory stuff that we're going to talk about in about 10 minutes. This one wants to know what's the molar mass. So PM equals DRT is the formula that I use. So the M does stand for molar mass. So we'll divide by P, and then we can plug in. So I'm going to show you something that's really cool. Density is mass per volume. Those of you who are in 151 with me, I actually showed you this trick. And then, so mass and volume. So this is my density. Now, it does need to be grams per liter. Whenever we do gas laws, gases take up a lot of space, so it's grams per liter. But you can leave it like this, and the milli cancels, and I am in grams per liter. So if you have the same metric prefix, even though the rest of the unit is different, the prefix will cancel out. So it's kind of a cool trick. So you can just write it like that, and it works. You can even look at how you did your math, and you're like, oh yeah, it does work. You can just state R. Pretty much everybody does that. And the temperature, we would add the 273, so we have 298 Kelvin. And then our pressure is, you can again figure out the pressure. That step I do need to see. I just show it within the problem. Then that's 1 ATM. So you would be dividing and dividing. And the units will be grams per mole. So that's what the M stands for, is grams per mole. That is the number from our periodic table. So this whole thing. All right, on number 6, we're solving for density. So again, PM equals DRT. There are other ways. You could do PV equals nRT, solve for moles, and then take the mass divided by the moles on this one. But this formula is just really nice. So this time we're solving for D. I mentioned this last week, and I will emphasize this again on Thursday. It is those of you in calculus, it's usually second year's calculus, who blow the gas law one, and it's really a bummer because you think you can rearrange the algebra in your head, and it turns out you don't. So state the original formula, and then you'll see that the RT goes in the denominator when we're solving for density. Yeah, you have no idea. And it'll be somebody, I don't know who it will be, who will just like say, oh, I know this. It's RT over PM, and it's not. So if you state it and then rearrange, you'll be okay. All right, pressure is our 234 millimeters of mercury. Again, we're going to change that to ATMs. I'm pretty sure if you did your own study set by now, you know that's 760. That capital M is the molar mass. So we add up the C2H5 and we double that. So, sorry. All right. So I got that it's 84. Somebody else get that? Grams per mole. Yes, no, maybe.
I got 74.
Is it 74? Really?
I also got 74.
Oh, it is 74. Sorry. Yes. Thank you. So that should be 74. And then R times the temperature, which is 296 Kelvin. And you'd punch it in, and just a reminder, it will be grams per liter. So density is grams per liter. Questions? All right. So there's our volume you can label. We have a temperature, so there's our T1. There's our P1. You guys can hear me okay? I have a weird buzzing going on in my head right now. And then this 34-ish grams per mole is the molar mass. So we don't have two of anything, so this must be, it just wants you to find how many milligrams. It's not asking for density or for the molar mass. So I just do it as PV equals nRT. You also could have done PM equals DRT, but again, I only use that formula if it's point blank, ask what's the molar mass or what's the density. So I do PV equals nRT, and I'm going to solve for moles. So we'll divide by RT. We'll plug in our pressure, which is the 123 torr. We plug in our volume. You do have to change your volume, so to milliliters. Why do you have to change, I'm sorry, to liters? So 10 to negative 3 liters to 1 milliliter. Why do we have to change it on this one? And then over R times T.
Because R is in liters.
Is it because of the R?
Yeah, R has liters. This will give you moles. And then you'll take that number, and we have that 34-ish grams per mole. And then a gram is 1,000 milligrams. And that's where I got around 2 milligrams for the answer. So I just didn't want to plug that in. We'll just say whatever that number is, gets you to there. So I broke it into 2 steps. So you can either do an arrow or you can just number your steps if you break them into steps. So just clearly label all your parts. All right. So we have a pressure 7.8 millimeters of mercury. So again, standard pressure is the 760 millimeters. This is really low pressure, but that's because we're on Mars. And we have a volume of 10 cubic meters. How many of you had to count your zeros? Did you count them right? Maybe half of you. That's usually what it is half you have to count them. And we compress it, and it just wants to know how many molecules. And there was hidden up there 27. The temperature is 27 degrees Celsius. So even though I wrote ones, I was anticipating that was going to be P1, but there's only one of each. This is PV equals nRT. You'll solve for moles. So PV over RT. Once you solve for moles, then Avogadro's number, 6.022 times 10 to the 23 per mole. And so you'll have the extra step. You can also do it within the problem, or you can break it into steps. And 2 sig figs because the pressure was a series approximation, because that's a really low pressure. So 10 to the 24th molecules or particles or whatever we're counting there. Great questions. I'm going to stop and then start again.